This session is going to be all about engineering, and we have Mr. A here, so hopefully you can see connections between what his students are doing in class and what you all do as professionals. So maybe we'll start just with each of you, given I know you gave us your descriptions and that's available for everybody, but maybe you could just speak to that a little bit, your journey, what led you into engineering, what motivated you, and kind of just bring us up to what you do currently. And I know you have a picture, so as you're talking, I'll pull them up. Anybody want to get us started?
I can start.
All right, Olivia, cool. I'll put your stuff up. Go ahead, Olivia, and I'll pull them. Give me a second to pull up, but while you can talk while I pull them up.
Awesome. Cool. So hi, everyone. I'm Olivia. I was an OHS 2018 grad, so I'm younger than both Dan and Mike. But I got into engineering because of my time in the robotics club. I was also a part of science research. And so all of that led me to Georgia Tech, where I'm now a fourth-year senior. In my bio, you probably read I've worked in a variety of industries at this point. I've worked in manufacturing, I've worked in chemicals, and I've also worked a little bit in kind of the aerospace and defense area. And that's what I gave Mr. Yonkler pictures of this morning. This summer, I'm taking a break from engineering somewhat and heading to Mount Rainier National Park to work as an assistant general ranger there. And so all in all said, where Mr. Albrecht is today at First Championships is somewhere that I've been 3 or 4 times in my time at OHS. And so without that, I wouldn't have gotten to where I am. And so that's a little bit about me.
Okay, I guess I'll go next. I'm Dan. 2015 is when I graduated. Didn't really not want to know what engineering I wanted to do until I took Albrecht's class, and then I decided civil. He made it interesting and fun. So that's how I decided to do civil. I ended up going to SUNY Polytechnic Institute in the beautiful Utica, New York. Currently, I work for WSP in Valhalla, New York, and do bridge inspection. So I think these pictures do a little more justice. That's from the city down in the Bronx. Pretty much just hit things with a hammer and hopefully it doesn't fall off. That's the layman of my job. And I enjoy every day of it. So that's pretty much all I do. Thanks.
Thanks, Dan. We'll go to Mike. I'll pull up his pictures. Then Olivia, we'll come back to you and I'll pull up your pictures. Sorry, it took me a little minute there.
Sure. Thanks, Yonkler. Similar to Dan and Olivia, it all started with the robotics team and the engineering course at OHS. I graduated actually 10 years ago in 2012. From there, took my skills to Manhattan College to get a mechanical engineering degree. Wound up working for a private company called STV in consulting, working alongside Metro North and New York City Transit on various projects. Yonkler just pulled up a faceplate, fiberglass reinforced plastic of the new subway cars that should be hitting New York in the next year or so. Those go by the name R211. So that actually was taken at a plant in Yonkers, the Kawasaki plant. You'll probably see it if you're headed southbound on the Metro North Hudson line last summer. My everyday pretty much goes from document review from engineering groups to inspecting rail vehicles out in the yards, working with people in Metro North, Amtrak, New York City Transit. That photo is me in actually Boise, Idaho, working on Metro North wheel sets, taking measurements of the surface roughness of the inner hubs of the wheel sets before they get pressed. And the next photo I think Yonkler has is a fully assembled wheel set for, you only got 3? 2? Okay. Yeah, those are the wheels before they get pressed onto the axles out there. But yeah, I currently work for Amtrak directly. I'm no longer in the private sector. I'm about 5 or 6 months into that job. We're currently working on new train sets that are being designed and built in Germany. So we'll look to have those running on Amtrak lines in the next 4 or 5 years.
Awesome. Thank you so much. And we're just going to pop back to Olivia now that I have some of her pictures. I can share those. And Olivia, maybe now that you heard from Mike and Dan, you can talk to us a little bit about how what you do kind of connects to them a little bit.
Yeah, sure. So I realized the most important part of what I forgot to mention is that I'm actually mechanical engineering. So this picture in the background you have with we call it, it's the V-22, and it's part of a new and up and coming Army contract. And so that's something that's semi-proprietary in that the sense that the general public knows what it is. And when I worked at Bell Helicopter, which is located in Texas, we get to do walkthroughs of the plane. We get to see a lot of really cool tests. And we also had a lot of officials coming through. And so that's something where not only did I get to use my engineering skills to work on things like that, you also get a lot of interpersonal and public relations skills because you're talking to people who don't necessarily have the background that you do in engineering. So the next picture is going to be, this is a manufacturing plant out in Minnesota for Bobcat, which is kind of like those little skid steer loaders. If you're familiar with what a skid steer is, it's one of those like little ATVs or small pieces of equipment. And so what I did out here is I helped make all these attachments that you see hanging on this huge, massive manufacturing line. And I helped learn how to package them and how can we make our packaging more efficient? How can we ensure that there's less damages? Does it make it through this new paint process all the way smoothly? And so what that means is making sure that there are operators in key locations to kind of check in on the products, blow off water and other debris as needed. And so you design things like these giant yellow platforms to make sure they can do that safely and it fits within your assembly line. And so the last picture is going to be, sorry, that's real small. My apologies. This last picture is part of working in the chemical industry. In the chemical industry, we work a lot with pumps, which is something you work on as a reliability engineer. And so we have our technicians who go out, and they've been doing this for years and years and years, and maybe don't necessarily have the degree that we do or that you'll get. And they can take apart a pump and tell you what's wrong with it. And what's crazy about them is they can tell you about what's wrong with it, most likely before they even take it apart. And they'll do things like tolerance testing so we can send all that info back to the manufacturer, get the new pieces in, and get pieces up and running again. And so I've done kind of a variety of internships that way.
Awesome. Thank you so much. I don't see Mr. Albrecht, but I know he's here. I wanted to see if Mr. Albrecht wanted to talk a little bit about maybe you all as students and what he sees in his current students and maybe give us a little bit about what he wanted to have happen this session as well. Go ahead, Mr. A.
So the one common theme with all of them is these three were awesome at figuring stuff out. They would take a problem, they would be willing to chew on it, they would go and look for the answer themselves. And that's something I'd love to have everyone develop. Other than that, they're three unique individuals who've done awesome things, and we're real proud of them. And thank you for coming in. So I'm going to turn it over to the kids in class. You guys can ask questions. I can talk about them all day long, but go ahead, guys. It's your show.
All right. So the first question, I'm going to stop sharing my screen here. First question comes from Liam and Jonathan. Did taking engineering in high school make it easier in college? Question number one. And that is kind of to all of you. So it did it. And if so, I guess I would follow up with that. You know, if it did, what skills or, tools or what experiences did you gain and how did you do?
And before you answer that, could I jump in?
Go ahead, Albert.
Engineering, any class that helped you in high school that made it better for engineering? Like, what did you have to do to get ready?
Okay. I'll put my 2 cents in. I think taking Albrecht's classes, I believe there's still two classes. I think it made it, especially the statics, getting introduced to statics a little earlier than just college. Helped a little bit, just the basic statics and all the basic things he went through. And I know he goes through all different types of engineering. And I think him touching on every type of engineering helps out tremendously because it also helps you choose what engineering you might like to go into, not just civil, us civil people, mechanical, electrical, there's a bunch. And your math classes, I think, definitely help tremendously because engineering is built off of math. So I think the math classes at OHS, especially calculus and any of that, especially if you take the college classes and then you get to college, you can skip those classes if you had the chance to do AP. So the more AP you take, it does help out in the long run when you get to skip those classes in college because you're already prepared to move forward. So those do play a vital role, I think, when moving into the next step in your education.
I will also tap in on this one. So like I said, I'm a senior right now at Georgia Tech. And what's really interesting is that this is a state university. Actually, it might sound like a private one, but it's a state university. And so a lot of our SUNY credits do transfer if you have the opportunity to take those anywhere else. And so you can save yourself and your parents a lot of money by taking courses at OHS and paying for them now. The other thing to note is with engineering, with working on robotics, with working on things in Albrecht's classroom, a lot of kids show up to college and they have never touched anything in their life. They're like, I don't know what this is. I don't know what to do with that. I've never heard of that before. And so, for example, right now I'm in a robotics course. It's a graduate level course. And people will code something up, set it on the floor. It doesn't work. They change something in their code. They set it back on the floor. And like, it's going to sound real simple, but one of the most important things you learn in Albrecht's class is like, if you're doing something and you're testing something, like if it fails, you have to run the same test every time. And so if you're in robotics, sometimes that's a matter of alignment. And so we pick up on those little details real early in his class. And a lot of people are sitting there like, wow, I got points taken off my test because I didn't mark units. And like, to this day, I have never, ever here had points taken off for that because, as you all know, you will get points taken off in his class if you leave off the units.
I will just say that calculus, physics in college was an absolute breeze due to the exposure at OHS through Cintas physics class and Gomez's calculus courses and all that stuff. So if you can get exposure to it early, you won't have to focus as hard on those courses at college, and you'll get to focus on more of the specific courses aligned with your degree.
Awesome. Thanks so much. Next question is from Lola. Other than this engineering class, what was another crucial class that you took in high school that helped you through your engineering career? I guess you kind of, I think, talked about that a little bit. What about like also, you can answer that as well, but spinning forward maybe to college and your engineering track through college school, was there a class that stands out as like super challenging, super fun, or any that you are memorable that stand out, and why are they? So your choice there, or both high school, college classes that were either crucial and or kind of just stand out in any way for you.
I'll take that one quickly. Pre-calc in OHS, I don't know if that's still offered. AP pre-calc and AP physics were the two that stick out to me the most. In college, I would look for any course that has somewhat of a programming aspect to it. So VBA is basically the macros behind Excel. Any Excel courses you can take, they really engage your critical thinking process, is what they kind of season in college. And Excel is a program that you'll find yourself using in industry on an almost everyday basis.
To piggyback off Mike, I 100% agree with the Excel. It's probably by far the greatest Microsoft tool out there to do everything for you. The better you get at it, the easier life will be in college with certain things, because it could do a lot. More than I'll ever know, but it does do a lot. For civil engineers, if you're thinking of civil, in college, I love my testing classes, testing concrete, testing steel, any really thing with hands-on. So if you end up going the civil route, that's what you're kind of looking forward to being able to kind of get your hands on real world experiences in college by testing certain things and really seeing where they break. It's the fun part when they fail. So
anyone else on that one? Olivia, you want? We could also, you could talk about classes. I also had a question about clubs and activities that you did that might have been related, and maybe you could spin that into starting to talk career, like, because the question was about activities or clubs that you did that helped you in your career and get to that career field and make you more comfortable. So things like that, clubs or activities, but also maybe how did you get your foot in the door, internships, connections, all that as well.
Sure. So I can take that one. Like I mentioned, I was a science research student. And so I did kind of our 3-year research program, and I worked at Hospital for Special Surgery, which is on the east side of Manhattan. And so kind of two things to be learned there. One is that getting that first experience is really hard, but when you take what you can and you use that to propel yourself forward, it's really easy when you show up here, because a lot of people are like, I've never seen like anything like an internship, or I've never done that before. And like, even if you're not in science research today, you have an idea of what it means to get that internship, because I'm sure you've heard people talk about it, and some people have never seen that before. And the other thing is, even if you choose not to do an internship, it's a really good skill to learn just how to talk to people, right? If you think someone's interesting, if you think what they do is cool, like reach out to them, ask, like it never hurts. Albrecht is always happy to talk about what he's done. And I think that's really important, because you don't end up with kind of that stage fright that other people might have when they're like, I don't know, I don't want to talk to that person because I've never tried that before. And so that's something that's kind of relevant. And so not only did I learn those speaking skills from science research, I took things that were outside of my kind of engineering and science focused world, and I did things like mock trial and getting to argue with kids from other schools, in a polite way, of course, is a lot of fun. And it taught me a lot about, how to speak in those professional settings with people that I haven't met before.
Dan, do you want to touch on, or Mike, either of those, on clubs or activities or extracurriculars or ways to get involved? How do you find those internships? How do you make the connections? Olivia has one more maybe, and then.
Sorry, I was going to say, it does apply to high schoolers too. There's a program through the National Science Foundation where you as a high schooler can apply to do research either locally, within the New York area, or you can apply to do it at kind of different colleges throughout the country, and they'll pay you a stipend for your time. And that's something that's really cool. So I just want to throw that out there in case you haven't heard of it. You can just Google NSF summer research and it comes right up.
I think any internship is a good internship, when you don't really know, wherever. It doesn't have to be specific to a certain engineering. I think you kind of just have to go out there and try to find it. Like Olivia said, use your resources, talk to people. If you don't speak up, people can't read your mind. So it's best to just kind of, even if you're nervous, take that step. I don't like public speaking, but you just kind of have to get comfortable in your own skin. But there are a bunch of internships out there. I mean, I've worked for the DOT. I did one with the wastewater treatment in Crotonville, 15 minutes away from here. So, and that didn't align with civil engineering, but it's an internship. It's under my belt, and I, got some valuable information from some experienced people there. So it doesn't have to be specific to a certain engineering, but you'll get vast amount of experience, just like Olivia said, again, talking to people, being comfortable with yourself, and then moving towards college, it'll just help you out tremendously. Starting in college, you'll be ahead of the game.
Yeah, agreeing with both Olivia and Dan. When you're looking at colleges, look for those alumni programs that some of them do offer. There is a bunch of programs, especially at Manhattan College, where alumni come back, they have dinner with you, they converse with you on what your interests are. And most of the time, if you communicate well and express interest and just show that you're excited about what you want to do, they will offer you either a shadowing role where you can just shadow them at work, or sometimes an internship. Most importantly, I think just getting your foot in the door in any industry is good. And I think Olivia said this: utilize your networks, utilize us three here, utilize any of the alumni from OHS. We're a small but great community. We keep in contact with Yonkler and Albrecht and a lot of other teachers at OHS still. If there's any opportunities that we see come up, we'll be glad to reach out to you guys and see if anybody would be interested. So again, reaching out to people, not only just by email, but picking up the phone too. I think that's most important, especially in today's world. We're kind of focused on our cell phones and texting and emails, but that phone call goes a long way.
Awesome. Thanks so much. And Mike, I like that idea of having like kind of almost mentors come back and talk to the current students about, what they're interested in and their career paths and make connections. Maybe that's another idea for future alumni days that we can do as well. So thank you for that. We're going to hopefully start to get a little more into the career stuff here. So I do have a bunch more questions. Kobe asks, how did you know engineering was the right career for you? And I might ask that kind of like in two ways. So the first part would be like, how did you know when you were interested in like pursuing engineering? And then the follow-up, the part B to that would be like, when did you really feel like, holy crap, I'm a professional engineer and I'm like responsible for stuff? Like, what was that first moment of like, when you found out you wanted to be an engineer, and then when you're like, wow, I really am an engineer?
I can take that first. I still have those moments on a probably yearly basis because we work on so many different projects. And when you see a project, for example, like a new train coming out and taking passengers from point A to point B, you really step back and say, my work or our work as a team is responsible for this, and we're responsible for the safety of the public. And so I always have those moments, even today. I've only been in the industry for about 6-7 years, but I have those moments a lot. But from the beginning, I think growing up, working with the hands, understanding, or visualizing how things work in your head was kind of my first start on knowing I wanted to become an engineer. Picking back the math skills helped a lot, but you have people like Mr. Albrecht who got their engineering degrees and found their love in teaching, and that's totally fine too. But I think an engineering degree is a good step in developing your mind to critical think and problem solve, which is what everybody in this world needs. So don't be hung up on going to engineering school for 4 years saying that you're going to become an engineer at the end. So because at the end you might not want to become an engineer, and maybe it's not for you. You could always take that degree and do something else with it. And I think having an engineering degree will be more competitive in across the board.
I think I remember specifically kind of when all of a sudden engineering kind of clicked was Albrecht's class. He had a statics problem, simply supported beam, and all he did was rotate it 90 degrees, and then nobody could do it because we're all new and we have no idea what's going on. And I just kind of just in my head rotated it back to where it originally was. And I was like, oh, it's the same thing. And right then and there, it was like a lot of these problems are the same problems, just at different angles, just at different ways of looking at it. So, and when you realize you can just problem solve by knowing it's the same thing, essentially just looking at it differently, it feels good. And it feels cool when, you problem solve all this stuff. And when you bring it to the real world, not just a line on a chalkboard. And it feels good, especially when you graduate. When you walk across and you get your engineering, your bachelor's, it feels nice. And that I think that's when when I saw that piece of paper, and after 4 years of hard work, actually being recognized as an engineer, and finally be able to put the hard hat on and be a real engineer, not just saying I was going to be an engineer. I think that's when it finally clicked that I get to practice this and enjoy my passion in life.
And so I will say something that's in line with both Mike and Dan, which is that if you decide to get an engineering degree, that's wonderful, because it means people always be like, your numbers must be good. You must know what you're talking about. And I love knowing what I'm talking about. It's great when people look at you and you're like, yep, I have the right answer. This is the best solution and this is why. And then to what Mike said is like, if you do this, you can do anything you want with it. Literally anything in the world. People will look at it and they'll say, like, she knows data, she knows how to talk to people, they know how to compute this, they know how to solve that problem. And so like the world is your oyster. And I mean that in the sense that like you can go and work on trains, you can go and work on buildings, you can work for apparel retailers and doing like their production lines or working on how they develop things. I'm going this summer to be a ranger. And they were like, you are a really great candidate, not because your background's in biology or people or management or anything like that, just because you've done so many things and you have an idea of how so many things work. And like, we see that you can take that knowledge and apply it to anything, and that's what engineering gives you.
Thank you so much for that. I'm going to use some of your words here to transition to the next question. Lima said, working with your hands and visualizing how things should be. Rivi, you mentioned like looking at things differently. And Olivia, you talked about some of the non-hands-on things like knowing how to compute and solve. Antonio asked a question that's kind of two parts, but did what you learned in high school translate on and off the field, I guess the field of engineering, right? But then the second part is where the transition from your quotes comes. How did you prepare for the less hands-on activities? And I guess what I would mean by this is like, what are your tips or strategies for our students here that are going into engineering of how to visualize things that you don't see yet, right? Like what are some of the tips or tricks that you've developed? Rivi kind of shared a little bit of a story about that, but maybe you have some strategies that might address visualizing things or things that are less hands-on. What are some of those things that you come across in your daily tasks?
My big thing is to draw it. If you can't visualize it, draw it, get a piece of paper and just draw it out. I'm a visual learner. So if you can't really visualize it in your head and figure it out, I recommend drawing it because it'll make it 100 times easier when you're physically looking at something you drew. That's what I would say is I'm a big drawer. I'll draw on anything, even a bridge to get the job done. So just draw it out.
Your second thing to know is most engineering programs in the country, regardless of where you go to school at this point, one of the first classes that you'll take in your first or second semester is a coding course. And they talk about something called pseudocode all the time. And pseudocode is a great way to think about a lot of problems. Before you start writing anything down, before you do any of that, like what are you going to do? If you can work out the logic, like you're already halfway there. And so a good way to relate this back to Albrecht's class is like, he always says, write out your givens, right? When you write out your givens, you see, I already know this. If I take my logic, I can get from step 1 to step 2 to step 3. And where a lot of kids also fail, not fail necessarily, but like in college is like, you'll see a lot of people jump right into solving the problem. They'll write everything down that they can, and they didn't really think about what it actually was. And so the whole write down your givens thing first, so you can think about what you're actually dealing with, is a really good first step to anything that you don't already know.
Yeah, tying into what Olivia said about jumping in, if you don't know at first, ask your superiors, ask your boss, ask your coworkers, because especially in engineering, since you might be in a situation where you're responsible for someone else's safety, you want to make sure what you're doing is the right thing. And it never hurts to ask the questions. So please, whatever you guys do, just continue to ask questions in high school, in college, and in industry. When you eventually get there, just ask the question. And you'll find yourself in a room full of engineers one day. No matter what age you are, there's always been someone there that's been doing it longer and may know more than you do. So listen and ask the questions when needed.
Wow, you guys are making Mr. Albrecht so proud here. When you said draw it, Rivi, the whole class laughed because I think they like heard him saying it. Then Liv, when you said write out your givens and start there, it made me as a geometry teacher proud. And then Lima, if not sure, ask for clarification, especially in a career that's so important. With you're talking about structural integrity of things, you want to make sure you're doing it right the first time, not only monetarily but safety wise. So certainly good, 3 good tips from you all there. You are all in different fields of engineering ish, right? So how would you recommend these students that are getting kind of like a little sprinkling of everything? How will they know which field is for them? What do you recommend for them in terms, someone also asked in terms of like courses that someone asked about courses. We'll get back to that in a second, but like how would you recommend for them to find their niche in such a varied industry?
So I can go first. I have 2 younger brothers. One just graduated from OHS about 2 or 3 years ago, and the other one is a freshman there now. And so when my younger brother was getting ready to go into school, and this applies to everything, like say you don't want to do engineering, you can do this with any job. What's really fun, honestly, is if you go on LinkedIn or you go on some job search website and you're looking at it, and like just look at like what looks cool. What do you want to do? When you read a job description, are you like, yes, I want to do that every day? Or are you like, oh my gosh, this sounds horrible, I don't ever want to do that? And that's a really good way to start. And then the second half to this is, when you get a degree, how many things can you apply it to? So like if you get a really niche degree, if you love that thing forever, that's super cool. That's like aerospace engineering. They really only work in aerospace. If you get a degree that's like mechanical engineering or more classical, like civil, electrical, what have you, you can apply that to a much broader range. So if you look at all these job postings and you're like, this looks cool and that looks cool and I can work in that industry, go for a classical. You can do any of those things. If you look at it and you're like, I want to work for NASA for the rest of my life, aerospace might be for you, or biomedical devices. That's how I've always thought of it.
No, totally agree with Olivia. Sometimes it's tough to figure out what exactly you want to do, even if it's not engineering. Anybody going into college, it's tough sometimes. But usually freshman year is just gen eds, depending on where you go to school, unless you skip all that from taking APs. So I've known some kids that do their freshman year not knowing what engineering they want to go into, see what their friends are doing, look at the course curriculum for all the engineerings at the school they're at, see, like Olivia said, what sticks out to you. What do you enjoy? Do you enjoy coding? Do you enjoy electrical engineering, circuits, things like that? For civil, a lot of hands-on stuff, water management, things like that. Hydraulics, it's the study of water, the flow of water. You like mechanical, dynamics, all that, so, freshman year does give you a chance too, but I would recommend starting sooner, since in high school, if you have colleges in mind, look at their pathway for each, every college has a pathway for their degrees. They'll have like a course curriculum of what you have to take. So like Ossining High School has a course curriculum that you have to take. So what sticks out to you? What feels, good to you that, this is something I think I want to pursue further in college?
Related to that, pay attention to the curriculum given by the college you're going for. So I was a mechanical engineer, and the curriculum at my school was heavily weighted towards HVAC systems and MEP, so a lot of building systems. And I didn't go down that route. So I would take my advice, and because I didn't take my advice, and look into the curriculum at college and see where they're weighting their course, their courses, and where they wind up, where most of the kids wind up at that college go to. Because I can tell you at Manhattan College, most of the kids I graduated with are working on building systems. I think I was the only one that wound up working in the railroad.
I just wanted to add one thing. What Mike said, 100% agree. Also, it's called ABET accreditation, which is look to make sure that the school you go to, and especially the engineering school, is ABET accredited, which is an accreditation. I believe it's a federal accreditation, if I'm not mistaken. Basically, that accreditation, I'm going to explain this wrong, but maybe Olivia, maybe you could explain it so much better than I can. Bring it up.
So the reason you want to find an ABET accredited school, right, is because when you graduate, you have the option to take your Fundamentals of Engineering exam to become an engineer in training, which Albrecht holds a professional engineering license that has maybe lapsed, maybe not lapsed, don't quote me on it, just because he teaches. And so he doesn't need it every day to sign off on his work, but y'all have probably heard about that. And so when you graduate college, you want to take this exam, then you work in a field for so many years, and then you can take your professional engineering thing. The problem is, if you go to a school that's not ABET accredited, meaning it doesn't cover like certain modules and curriculum, you can't take the exam because no one has spoken to the goodness of the program at your school. And so it's really important to go to an ABET accredited school, because if you do that, some fields do require that you get your FE and then your PE, so your Fundamentals of Engineering license and then your professional engineering license, like I said. And you can't do that if you didn't go to a school that the overall like engineering board, either in your state or for the country, depending on what sector you go into, has said, yes, this is a good school. They teach good factors, good math, et cetera, et cetera, et cetera. So that's what Dan's talking about. You don't have to get that deep into it. Most schools are ABET accredited. It's unlikely that you find one that isn't, but it's a good check mark.
Keep it on the radar, right? Okay, next question is from Jonathan. CAD is a very useful tool. What do you use it for? Maybe you can just give us like the coolest application or the most, I don't know, interesting or the most memorable application of CAD that you've each used.
Yeah, as an intern, CAD, AutoCAD was basically just 2D drawings for plan drawings and layout drawings. But I think most importantly, especially in a world where we're communicating virtually, learning or getting used to viewing 3D models as a whole, countless times throughout the month, we're pulling up 3D models in meetings remotely, going through a train design or a car design and looking at things on a 3D model. And I think that is so important, especially nowadays. There are, specific job titles in the engineering field where you can just become a CAD technician, where it's just drawings and it's a whole separate 8-hour, 40-hour a week role for some of these companies. But I think one of the programs are constantly changing, but Revit, REVIT, is one of the fundamental and most important tools that I've come across as far as 3D modeling and 2D goes.
In my day-to-day, I don't use CAD because I do field work all the time. But obviously, I learned to use it in college. And like Mike said, people do it for their full profession. And I would highly recommend if you have the opportunity to further just have that as a piece of what you do in college and have it in your resume that you're very proficient in CAD. It sets you apart from the rest of whomever is applying for that job. The coolest thing I ever did in CAD, I built a house my freshman year. That was probably the coolest thing I did in CAD. But Revit, like Mike said, is a phenomenal tool. I mean, you can look at shadows and the sun rising. It's pretty cool. That's another program you may see when you get to college. But those to know how to do, they do set you apart when you end up applying to jobs.
So I'll give y'all some applications on a college level, which is I at one point had to design a robot for a class. You design every component. You either laser cut, you CAD it. Like you have to know how to do that to make sure these things are going to fit. When you do research, you learn a lot of new softwares. And so if you do additive manufacturing, you're going to make parts in CAD. The other cool thing that people do that's not necessarily class related is if you've ever heard of Thingiverse, that's where people will upload all types of things and people will print them for fun. And it's always really interesting because if your school has a makerspace, there's going to be someone there printing something very strange. So something to keep in mind.
Thank you so much. All right, I think we have time for one more because we're nearing the end. And thank you so much. It's been amazing. And we have some great questions from students here in engineering too. Jennifer asks, and we kind of have a two-parter again, who is your biggest inspiration? And maybe just each give us like a 30-second, like give us a person and why a little bit. But then I also wonder, like, where are you headed in your journeys? Like, what do you hope to be, eventually at your pinnacle in your career? So maybe just like a 1A, 1B kind of question here, and we'll end with that.
Sure, I'll do 30 seconds first. Last summer, my supervisor was a woman by the name of Paula Jackson, who got a degree in accounting. She is now the head of facilities at Bell Helicopter, which is where you manage projects in the billions of dollars. She taught me that you can get anywhere you want to be and you don't necessarily have to get there the way people think you should. And so where do I want to end up? I don't know yet. It's kind of important to figure that out along the way with everything that you learn about yourself because it always changes.
Thanks, Olivia.
Yeah, I'll say personally, I don't know if I have a certain person who I'm inspired by completely. I think I have had many people throughout my life, many bosses who have showed me how to work with people and how to manage people. So I've taken that with me. But I think I take things week by week. I don't know. I'm not sure. If you asked me 5 years ago that I'd be working for and told me that I'd be working for Amtrak in 5 years and I'd be where I'm at back in New York working here, I would say, yeah, right. So you have to take things, kind of a little bit slow and just keep chugging along and go from there. So I'm not sure where I'll be in 5 years.
no, there was a teacher in my college that I ended up bonding and becoming close with who, you always find that one professor that kind of sticks around more than the rest. And I think just, him pushing and me seeing how just the way he did things and all the accolades that he had, I just kind of want to be like that. And I'm not as smart as him, but I think I can get there one day. And, like Mike said, day to day, can't really get ahead of it. You'll get very frustrated if you try to get ahead of it. Things come and go in this world, and in the engineering field, you're going to fail, and that's okay, because we learn a lot more from our failures than we do when things work, and things will not work 100% of the time, especially in the engineering field. So okay, you're problem solving. That's it.
Thanks, Dan. Olivia, thank you so much. We appreciate your engineering too. Thank you so much. Lots of live streamers at home, so we really appreciate it, or in their classes. Thank you so much, guys.
Thanks, Yanko.
Thanks for having us. Bye.
All right, thanks so much for your time.